All right, today I'm going to talk about a fun chop that I've come across called the copy chop. I'll explain a couple examples of how to use it. I'll first start off by giving just a quick overview of what it does. Then I'll be talking through this example where I used my keyboard to control these two jumping tubes. This is just one small bit of animation that's being copied in time to my key presses. And then I'll go into more detail as well about this example, which you may have seen if you follow me on any social media. You probably saw this post. This is a setup where rather than triggering animation curves that are copied by user input, we're using just information from our scene to trigger those copies. And this one single animation is being applied to these clones or these instances by way of offsetting their it's a time offset of a single animation applied to these copies. So two really different ways to approach the copy chop, and I'll talk about both of them. So let me start just a clean geometry node here. And we're going to start by building an example that's similar to this first one. So let's hop in and get going. So I have a geometry container here. I'm just going to rename this tube single. And let's drop a tube down. I'm going to make this a good bit smaller. Just do this in the viewport. You can do that in the parameters as well. I might as well do it in the parameters, I guess. Say 2.5 in the radius. Let's just do 0.2 for both of the radiuses. I'm going to add end caps, and I want this to always sit on at the origin. Copy the height parameter. Copy this. Paste it as a relative reference. And then divide that by 2, so that no matter how tall this cylinder is, it'll always rest at the origin, because its y position is always going to be half of its height. I'm going to add a transform SOP. This is going to be where I add my animation. And so just really quickly, I'm going to add a couple keyframes, the translate x, y, and my rotate Z. Will come out to 24 frames, and just add some more keyframes here. And I want this to jump. I want it to look like it's jumping. So just take that up in my Y position. Then I'm going to tweak my curves just real quickly. I want my Y position to really come down hard and maybe hang in the air a little bit longer. And I want my rotation value, I want that to be weighted more heavily towards the beginning of the animation. I don't want it to be still rotating when it's at the end of its motion. So that's probably a bit too much, because it's actually going through the floor. Or if there were a floor there, it would be sort of going through that. All right, and then I want my X position to kind of be the same as the Y. I want it to go ahead and get there quick. And oops, I did that the wrong way. I want it to go ahead and move out faster from the beginning and slow down at the end. That's maybe that's too fast, but I think that'll be fine for our purposes. You can finesse that as much as you would like, but just for the sake of keeping everything moving, that's going to work great for us. And I'm going to call this my ref. My ref animation, and you'll see why in just one quick second. I'm going to drop down a chop network. This is where the bulk of our operations are going to happen. I've also split my pane over here and I'm looking at a motion effects view, you can get to that through here. I'll leave that in my scene view. That hopped to an old chop network that was in one of my examples. That's where those nodes came from. So I'm gonna open this, and the first thing I need to do is, we're using the copy chop, so let's grab one of those and take a look at some of the take a look at what this chop expects. It really functions much like the copy to points, whereas if this were a copy to points SOP, what it would expect is incoming geometry to be copied, and so you can think about this as the incoming animation curve. Well, this is flip-flopped actually. So this expects the incoming animation curve, the required copy, the channel to be copied, and it expects the template onto which that copy is going to be applied. So it's the same concept as a copy to points, but the inputs are sort of flip-flopped. So what we want to do is we want to bring in those animation curves that we have. Let me just pop back up here real quick, and I'm going to open this up in my animation editor. To get to this animation editor, if you don't know the hotkeys, just hover over any animated parameter and just hit the V on your keyboard. That'll bring that up. I'm going to pin those. And what we want to do is we want to bring these curves as references into chops. And the easiest way that I've came across to do this is by using the channel chop. The channel chop will let you animate directly in it. But rather than animating directly in the channel chop, since we already have the animation built, I'm just going to reference these in. So I am going to, I feel like the cleanest way to do this, when I was building this out originally, I just referenced one of these values into each of these. But I feel like just for cleanliness, I'm going to make 3 separate channels within this channel SOP, or I'm sorry, within this channel chop, and I'm going to label those appropriately so that just to avoid confusion. So the first thing, I'm going to just add a couple channels here. So we've got 3 total. The first one I'm going to call TX, and that's based off of what this is called in SOPs, our translate X, translate Y, and our rotate Z. Okay, and now all I'm going to do is I am going to copy my translate X, and in this field I'm going to paste a relative reference. And then I'm going to do the same thing for each of the others. All right, now if we look in chops, our set of curves should match. So this is our rotation curve, and the others are just values from 0 to 1, so they appear much smaller because the rotation is from 0 to 360. This is our Y, and that is our X. So we have this, in essence, we have the exact same curves from SOPs now referenced in chops. And let me just grab this translate Y, and you'll see that we can update those, and our curves update live here. It's just a reference. So I'm going to close our animation editor for now. And now what we want to do, so we have half of what's needed for our copy chop, and now we need a template. If you were thinking about this again in SOPs, you'd need template points to copy these curves onto, but in chops we only deal with channels, so we need a template channel. For this demo, I'm just going to use a pulse and just show you what the pulse is. This will give you, based on your input parameters, will give you a pulse of the value of 1 as frequently as you tell it to. So I'm going to use that to copy our value onto. And if we middle mouse on this, we only have 1 channel. And so right out of the gate, we've not got it set up exactly right. We're almost there. But what we need to change in this instance is we need to change this output method. Instead of giving one channel per template channel, we want one channel per copy channel. And the difference is we want to copy, we have three, in essence, we have three channels coming in here, and we want to copy each of those channels to each of these impulses. Whereas if we left it at its default state, it's just going to copy the first channel. So, but we want to get all of them. So let's say that. So now we've got our animated curve being copied in time everywhere this pulse is happening. And this pulse can be anything. It can be processed audio. It can be a keyboard input. It can be whatever you can think to do in chops. It can be that. So now these curves are, as of right now, only exist in chops. SOPs doesn't know that these exist, and that doesn't know what you want to do with them. So we need to tell Houdini to take these curves from chops and to apply those somehow in SOPs. So we have our reference animation here, and now I'm just going to leave this to the side. And let's drop down another transform, and let's call this xform copy. You can call it anything you'd like. Okay, so this is going to be what receives these curves. And I haven't shown this way to approach how to assign curves yet. So this is a new way that we're going to do this. In past tutorials, we've done references by dragging and dropping. We use the channel SOP to bring things in. This time we're going to export. And for multiple channels and being assigned to multiple values, this way I feel like is cleaner in this instance, but you may be able to do this a different way. I just felt like this way was the cleanest. So what this export chop is going to do is it takes whatever channels you feed into it. That's what this wildcard is. And you can scope this out to just your rotation, just your transform, or just one of the channels coming in. But I want to take all of my channels, TX, TY, and RZ. I want to export all of those out. And it says, where do you want to export them? So I want to export them to my object context. I am in my tube single, and I want to put them in my xform copy transform SOP that I just created. Okay, so this is an explicit path. You could also do a relative path by just typing .. xform copy. It would do the same thing. So this is part of it. And then the last thing we need to do is just to check this export flag. And you can see right away when we do that, something happens in our viewport. And we have, just by setting up that one chop, we've exported all of these animation curves to their appropriate channels. And why that is, if you look at the parameters here, and as soon as you click that export flag on your chop in SOPs, the channels that you've assigned will be flagged as orange. So if you were to hover over any of these, you see, if I move my mouse, it's going to go away, but you'll see the RX, RY, RZ, SX, YZ. So this particular SOP has channels that are named the same way that we named our channels here. So this export chop will say, okay, you want to export these channels to this SOP, and if there's any parameters that have these names, it's going to export everything coming in to those parameters as you've defined in these parameters. So that may be a little confusing. I hope it's not. Yeah, have a play around with it, and I think it'll make sense to you. There we go. I lost everything for a second. And there it is. What's nice about this is the curves. It's additive by nature, which is really nice. So when I first stumbled across this copy chop, what I thought would happen would be that it would apply the animation curve, then zip back to 0, then apply it again. But what's really nice is it compounds all of the motion, because it's always adding to where it is at that time step. So I think this is really cool. Just to show you how I did it, I'll drop down a keyboard chop and a record chop. The record chop will record any incoming channel, and the keyboard chop, what that does is it will take a keyboard input and give you an impulse based on your key press on your computer's keyboard. The trick to it is you have to be in intercept mode, and for it to record you also have to have a record chop down. So now if I press play and just start hitting the 1 on my keypad, you'll see this little animation happening in real time. So if you want a more in-depth explanation of that keyboard chop, I have a standalone tutorial that's all about that. Feel free to check that out. I'm going to move on to the next example. Again, just trying to move relatively quickly for the sake of time. If you're playing around with the keyboard chop and then you start typing and nothing happens, it's because you need to exit intercept mode, or like tab won't work, or any key presses really won't work at that point. So you need to turn intercept mode off. And let me drop down another geometry stop. I'm going to call this one tube copies. Tube copies 1, actually, because somewhere in my working file I have one already named that. I want to copy my animation. There's no sense in wasting time creating that again. So I have my reference animation, which is just a single jump. And in this case, what I'm going to do is I'm going to create several instances of this using copy to points. And then I'm going to, inside of a for loop, I'm going to offset my animation based on information in the scene. So let's start by making our points that we're going to copy this tube onto. I chose to do that with using an add SOP to create a point. If you're not familiar with doing this, it's just Houdini's way of adding a point with coordinates that you define here. So it's just a single point, and then I'm going to use the copy and transform to give myself a line of points. And the reason why I did this in short version was so that I could get that sort of spirally motion, and I'll show you how to achieve that later. This is just the way that made sense for me to do it. I'm going to start with 10 points, and I'm going to spread those out. So what this is doing is this is saying, okay, we've got 10 points. Each point, move it point. Let me actually make that 0.25, I guess. Move it 0.25 units from its previous copy. So play around with the copy and transform if this doesn't make sense, but I'm just using it to make a line of points. And then I'm going to use the copy 2 points to copy my reference animation onto my points. And actually, let me space these out quite a bit more. Let's just make them one unit away from one another. And right now, we've got our animated tube copied onto our points. So what we need to do is, and what I did in my previous example that you may have seen, or that you saw at the top of the video, is I had a dynamic sphere that just sort of rolled through the scene, and as it crossed these template points, that was my trigger event. What I'm going to do is I'm just going to animate this sphere rather than have the dynamic one, because for demonstration purposes it doesn't matter. I'm going to template those. Let me change this to a dark background just so it's a little bit easier to see, and disable that grid. I'm going to animate this from that value all the way down here. Ooh. Oh. let me disable my animation. I thought that I wasn't even crossing the I thought that I wasn't crossing the position of the points, but it was just because I was at a later part of the animation there. All right. And so the way that I chose to sort of register this event of the sphere crossing the point was, it's really simple. I'm just using a group, and what I'm going to do is I'm going to group these points. So change that from primitives to points. I'm going to group that based on bounding regions and bounding object. So when the second input's geometry, when that crosses over the my template point, you can see that that point becomes part of group 1, and when it's out, when the sphere leaves, then it's no longer in group 1. So that could be enough to take into chops, but what I typically will do is I'll create an attribute, because it's easier for me to bring an attribute into chops than bring in a group of points coming in and out of a group. So I'm going to drop down an attribute create. I'm going to call this attribute, let's see, trigger attribute. So I'm going to rename that attribute trigger, set its value to 1, and limit it to the group 1, so that if we look at a geometry spreadsheet, anytime there's, if you can see this, anytime any of these points is in group 1, it will also have an attribute called trigger that's value is 1. And that's what we're going to need going into chops. So I'm going to call this null to chops, drop down to chop network, hop inside, look in our motion effects view, and we're going to need a few things in here as well. We'll obviously need our copy chop. We will need another channel, and this time, rather than a pulse to generate those the template points or the template channel, we're going to need a geometry chop, and this is where we're going to bring in that trigger attribute from SOPs. So let's go ahead and point 2 levels up. The // references our current network. If you do another one, that'll reference 1 network up, which is our SOP network, where we've created this 2 chops null. So we point it to that, and we say we want to bring in our trigger attribute, and we're going to rename that to, in this case, we're going to, we'll just call it trigger. Just keep it clean. It may be confusing, but hopefully not. So what this is doing, this is saying, okay, you have each of these, you can see our channel updating. At each of these, this is the wrong way to do it, but you can see that our channel is updating with our attribute. And what I'm getting at when I say this is the wrong way to do it, when this geometry chop is set to static, it's treating these 10 points as one piece of geometry and creating one channel, and at each sample of that channel it's registering the attribute value. But what we want to do is we want to treat this as an animated piece of geometry, and now we will get a discrete channel for each point with the channel that's the length of our entire timeline that represents the value of this attribute for that point. I hope that makes sense. So if this is set to static, it will treat your incoming geometry as one channel with the attribute, your scoped attribute, at a specific sample point of your channel. If this is set to animated, it will bring in a discrete channel for each point with that channel representing the attribute value that you've scoped here. And this is what we want, because we want to use these channels to offset our animation per point. So we need a channel per point. So I don't want to belabor that, but this is what we need. So we're going to wire that into our template, the template side of our copy chop, and our channel that we're going to copy. Since we're going to be retiming something, we don't necessarily need exact representations of our animation curve. We just need something that will we'll need a value from 0 to 1 to map that retime to. So I'm going to go ahead and make a channel that is a simple curve from 0 to 1. And when we look at our copy, we can see that at each of these triggers where the ball, and let me do this as well. Let me template both of these, and I'll just pin this. If you don't pin this, you won't see it when you come into your chop network. So now, at every time when this ball crosses that point, now we have a nice smooth animation from 0 to 1 that will be an attribute that is mapped to this point. All right. Again, hopefully that makes sense. And this curve can be anything. It can be a more complicated curve than simple 0 to 1 if that's what you're doing. Like if you're not driving a retime, if you're driving a scale attribute, p scale, or something else, this curve can be anything you would like it to be. But for our case, for a retime, a simple 0 to 1 makes sense. So this is all we need out of chops for this setup. So I'm just going to call this out to be clean, and come back into SOPs, disable those template flags. And now this is very similar to the way that we took information out of SOPs and referenced that inside of our chop network. Now we need to reference the information out of our chop network back into our SOPnet. So a really easy way to do this is if you just pin this window, and then just go back inside your ChopNet. Then you can just drag and drop your reference. You can do it a lot of ways, but that's a really simple way. Now, since we brought our geometry in as animated channels, giving us one channel per point, we need to bring it back out the same way. And because we're operating on our trigger attribute, that's what we need to that's the channels that we're bringing in, and then we need to say which attribute we are going to apply that to. So we're going to apply that to, just to make sure this is working, we're going to apply this to a p scale. And the reason this is giving an error is because this is saying that there is no p scale. There's no p scale attribute in our scene to apply these values to. So let's just create that. We're going to change the name of this in a minute, but let's go ahead and create this just so that we can. I need to spell that correctly. All right, now we should be good. What is it? Let's see what this is telling us. Oh, I have these in my group channel rather than my chop channel. Okay. So once I put that in the right field, our error went away and we're ready to go. So the reason I chose p scale just as a temporary parameter to drive is that our copy to points recognizes p scale and will scale our copied geometry accordingly. It'll do that by default, just because p scale is a recognized attribute. So we can see that this is working. Like we're getting these curve values out of chops back into SOPs, and we're applying those to our copies. So this is working as we would expect. I want to pack those as well. I don't want to, just to be a little more efficient. So that, yeah, p-scale is not what we want, but we know that our system is working. So now, rather than applying these curves to p-scale and having these scale down, let's create a new attribute that we'll use to drive this animation. I just called this play. You can call it, you can really call it anything you want, but offset would probably make more sense, but whatever, I call it play. And so let's turn our animation back on. This is still all happening at once because we haven't changed how this is being interpreted yet. Let's drop down a time shift, because what we want to do is rather than copy this geometry, rather than copy this side of our node tree to all of our incoming template points at once, let's use a for each point loop. And what we're going to do is we're going to do our copy inside the loop. And the reason being is, in a loop, we're not doing this all at one hit. We are, if you've ever played with loops, it's really helpful to troubleshoot them by looking at one iteration of the loop at a time. So for each point present in this geometry string, it's going to copy our instance onto that single point. Now the result visually looks the same, but the difference is when it's iterating over these points, we can then reference the play attribute that we created that goes smoothly from 0 to 1. You can see it updating right now. We can use that to control our time shift. Whereas if we were doing this all at once, the time shift SOP it won't operate like that. You need to, it operates on whole geometries at once. So if we treat each point as a whole geometry, this will work, and we can reference that play attribute and everything's happy. If we try to do it all in one shot, it won't work. So let me show you how to set this up using I'll set this up using a point function. So all we're going to do is we're going to use the point function to pull a point attribute value into the frame offset field. And you can check out the help card on this. It usually will bring up a little black and white help card on there it is. So all we're going to do is we're going to point to this first node in our for loop, for each begin 1, and we're going to put that in quotes, and then just sort of follow the directions here. We're looking for the 0th point because within a loop there only ever is one point. The attribute we're referencing is play, so put that in quotes, and then 0 as the value because it's not a vector value, it's a float value, so there only ever is a first component of that. So if we hit enter now and just click on this to stop showing us this expression and show us the evaluated expression, so we can see that we are going from 0 to 1. So our frame is in essence going from 0 to 1. But that obviously that won't get us through the end of our animation. Our animation goes from frame 1 to 24. So we have a couple options. And I think which option you choose sort of depends on what your preference is. Do you like to use expressions, or would you like to have something that's a bit more visual? Going the expression route, you could do a fit range, and you just say fit this value from 0 to 1, which it currently is, to 1 to 24, and that would do it. Now if you want to do it a little bit more visually, or just to keep things operating in chops, you could change your animation curve here from let's unpin this. This is our original animation. You could change this from 0 to 24, and that'll work just fine. And now our animation's happening. Or if you don't want to even do that, you can drop in a math, because this has a change range, and then you could say from 0 to 24, and this will do the visually. All these solutions are the same, whether you choose to do it through an expression or doing it in chops. However you want to do it, you'll end up in the same place every time. And so now in our loop, if we turn off this single pass option, we're going to see the result of that the full iteration of the loops for every point. And that's doing what we want it to. But obviously there's a problem. Like if we merge, let me just put this over here. If we merge our sphere onto the copied tubes, and let me just do this as well. Let me do a connectivity, and that's going to give me a class attribute that I'm just going to give myself some random colors based on that attribute, just to make this look a little bit nicer. Random from attribute. My attribute is class. So now we've got randomly colored tubes. The biggest issue is that the sphere is just it's clipping the geometry. So a really quick solution is just to time offset our sphere backwards. So we're going to say the current frame $f minus 12, and that should get us, give it half a second to go, and it looks like our tubes are jumping out of the way as the sphere is coming. All right, and so this is the basics of how to set that up. Now to get the nice sort of curly path, I'll show you how to do that. Now you can add more points to this as you would like. You would obviously need to give your sphere further to travel as well, and all that. All this is still, I'm scrubbing through, I'm not playing, but it's all real time. This isn't a heavy scene. People will be very fast to tell you that chops will bog down, that chops doesn't scale. And I think, and it's true. Like if you're scaling this to 10,000 points, it's not going to be snappy. But if you scale it up to a few hundred, it's probably going to be fine. So it just depends on how you're using it as to how performant it's going to be. But for me and all the simple examples that I've done, it's been really fine. So the next thing we want to do is just to make a little bit better pattern out of these. What I need is a point normal, and the way that the normal SOP, if you just drop down a normal SOP and say, all right, let's see some point normals, it's not going to work, because the way that it calculates point normals is based on like face orientation and point winding and things like that, which when you only have a single point, you don't have those. So I wish there was a way, and there probably is, I just couldn't think of it. I wish there was a way not using Vex for people who might not be familiar with Vex to do this. But the quickest, easiest way that I found to get a point normal on a single point is just to explicitly define that by saying a vector at normal. So V just means that you're defining a vector, and the at sign is an attribute, and the n is your normal attribute. So I'm going to say my normal attribute is equal to, and then I'm just going to define a direction here, and I'm going to define that to the z axis. So xyz 0, 0, 1, and now I have a point normal right there. And I think yep. Usually those are blue. I'm not sure why that's that teal color. Maybe, I don't know. So now I have my point normal, and if I look at my copies down here, I'm going to look at them after the animations happened. Now on my copy to points, these transforms compound, right? So if you look, I can say I'm really only moving my points 1 unit, but it's 1 unit times whatever instance of that point it is. So if I were to just start to rotate these a little, I start to get some pretty interesting patterns. And so I don't remember the exact values that I typed in to get the sort of the nice spirally curve that I had in the example I posted online. But this is how I did it. So you just kind of have to play with the number of instances you have and how far they are offset from each other in space, and how much they're rotating. But now you can see those are sort of jumping in a little bit better pattern. If you turn the sphere back on and turn our normals off, get rid of that transform handle. There you go. That's pretty close to the animation that I had. And the other cool thing, like you saw, this is one of the things I really like about Houdini, is after the fact, you say this is not perfect by anybody's stretch of imagination, but say that it was, and then all the way at the end you're like, oh man, that one tube out there is just killing me. It's just hanging out there and it's getting intersected by this sphere. Well, what you can do is, if you just select that one, type transform, when you select something in the viewport and do a command, it will default this sort of set a live group as you're going. And now I can say, well, actually let's just rotate that one over here too. And I haven't screwed anything up because it's operating sort of last in line, right? So any information coming into this hasn't been affected, and so I've sort of saved myself a lot of headache by cheating right there at the end. And the other cool thing, like let's say these I spent all this time setting this system up, and my animation is not high enough. Like the tubes aren't jumping high enough. You can just pop open your animation curves and start tweaking these values, and the whole system evaluates. It doesn't take, for a setup as easy as this one, it doesn't take any time for all the chops to recook and all the things to be copied and reapplied. It's really instant, which is I think is just really amazing. So those are the basics of how you set up the copy chop to both apply a predefined animation to a single object, and you can control that any way you'd like with audio, with your keyboard inputs and MIDI input, all kinds of ways. And how to take similarly how to take that concept and apply it to instances of objects. And I will clean up this file. I'm going to keep this tutorial on the shorter side, but I will clean up this file, and it will include these other let me unpin this. It'll include these other quick setups as well, which are very, very similar to what we just went over. This one, all this is doing is it's a pop net where these particles are hitting this outer sphere. The pop network will give you a lot of attributes dealing with like hit positions, and I used one called hit number and used that inside of chops to generate my my trigger channel, and then I just mapped the p scale of the particles to that. I copied it via the hit number, and maybe I will just show it real quick. My curve that I'm driving my p scale with, it starts really close to 0, climbs up and then scales back down. So I'm getting a sort of an illusion of a more complicated system than it really is. So each of these channels is copied a ton of times because I have a ton of hits. But again, it plays back better than real time, even dealing with far more instances of these channels than we were dealing with my tube examples. So I'll have that example in there, as well as this radar example, which is sort of the same thing, where I'm using events from SOPs, where this line where it crosses some scattered points, again, just applying a p-scale to that. And then the last copy, by far the heaviest of any that I have, by far the heaviest that I have is this. Again, just a copied animation of these cubes flipping over, which doesn't particularly look good, but it was where it's where the idea for this tube animation came from. It was the first iteration of that. So this file will be up on Gumroad. I hope that the explanation and the walkthrough were helpful for you, and I hope that it spurs some ideas to pop open Chop Network and get to playing around. If you want to check out some of the older videos I have, check out my playlist of different Chop setups where we go over audio processing, keyboard, mouse inputs, and various other cool setups with Chops. Check those out on YouTube. Give me a follow there, subscribe to the channel, or give me a follow on Twitter for more updates. Thanks so much for your time. I hope it's helpful.